Lesson 71, Making and Analyzing Scatter Plots. First off, what is a scatter plot? Scatter plot is just a graph that relates two sets of data with plotted ordered pairs. And with these plotted pairs, we can draw a trend line to see where our majority of our points landing. They're not going to be in a straight line if you were to connect them point to point. So the trend line is just a line on a scatter plot that touches as many points as possible. Many times it's just going to go through the center of where all the points are, touching majority of them. And then the line of best fit is just a trend line that shows linear relationship of a scatter plot and the most accurate plot the most accurately. So it's just going to be the closest line we could. If it was all on one line, that's the best and most accurate way to describe a line. So let's look at an example of a scatter plot. Here, this one is done for us, but the one thing we want to do is find the equation of the line. You can see if they were to connect the points, they would not make a straight line. So they drew their line through the middle of where majority of the points are, touching almost all of them, only going through a few of them. And I'm going to highlight these two here because those are the two that you can tell that they go through. You could have chosen this last one, but to make it easier, I'm just going to use the fourth and fifth points. We're going to use the slope formula, y2 minus y1 divided by x2 minus x1 to find the slope. So it'd be 23 minus 18 over 5 minus 4, and that would give us a slope of 5 over 1. Then we're going to pick a point. It'd be best if you pick one of the points that it has to be a point that's on the line, but let's choose the point. We could choose any of the points that are on that line. We can use the 418. We could use the 1, 4. We could use 523. To make it easier, I'm just going to choose this one. So I have y minus 18 equals 5, our slope, times x minus our x term, which is 4. Distribute the 5, and I get y minus 18 equals 5x minus 20. To get y by itself, I add 18 to both sides, and I get y equaling 5x minus 2. So that would be a decent or a very close equation for our line that we have drawn here. Now somebody else, if they chose a different point, slope would be pretty much the same. It's just where the y-intercept is going to be located. But for the most part, whatever points you choose, as long as your points are on the line, your equations are going to be fairly similar. So now let's check one ourselves. It says find a slope, or make a scatter plot of the data table here, and then draw a trend line on the scatter plot. Then find an equation for the line. So here we have our points, and the x-axis I'm just going to count by ones, and then my y-axis I'm going to count by tens. So 10, 20, 30, 40, 50, 60, 70, 80, and then 90. Then we're just going to plot our points now. So 114, so that's roughly here. 227, be roughly here. 343, see around here. 453, here. 570, 685. So that one's fairly close to a straight line. So now let's just get a ruler out here and we'll draw our best fit line. Okay, that looks close, so I'll just draw my line here. Okay, so now we pick our 2 points that we want to use to find the slope. I will choose I'll choose this first one and this last one. So that's 114, and we have 685. So let's find the slope. So 85 minus 14, but I'm going to make that 15 just so my numbers make it a lot easier to do. So 6 minus 1, so this would be 70 over 5, which will give us a slope of 14. And so now we have a slope of 14, and I'm going to use this point 114. So y minus 14 equals the 14 times x minus 1. If I distribute the 14, I have y minus 14 equals 14x minus 14. Get y by itself, I add 14 to both sides, and I get y equaling 14x, and then there's no y-intercept. This would be my equation of that line, and that would be a very good estimate for the equation of that line. Next part, looking at some correlation and how you describe the trend of the points. So correlation just means the measure of the strength and the direction of the association between data sets or variables. And with the correlation, you can have a positive correlation, which just means the data value for both variables increase. So it goes up from left to right. So think of a positive slope goes up from left to right. Same thing with the correlation. Positive correlation goes up from left to right. Negative correlation, data values for one variable increases while the other one decreases. So it goes down from left to right. So when y decreases, the x increases. So let's take a look at some examples here. We have a strong positive correlation between x and y because as the x gets bigger, the y's get bigger. So our slope is a positive slope. It's going up from left to right. The middle one has a negative slope. It's going down from left to right. When y is going down, x is getting bigger. So we would say this has a negative slope or a negative correlation. This last one has no correlation because there's no pattern of where the points are located. Some are up, some are down, they're all scattered all over. But that would be an example of no correlation. So let's identify these. Letter A, this one it's going up from left to right. So this is a positive correlation. This one, my x's are going down, but my y's are going up. So they're going in opposite directions. So if they're going in opposite directions, we would say this has a negative correlation. The height and your shoe size. So does that mean the taller you are, the bigger the shoe size you wear? Or the shorter you are, the smaller the shoe size you wear? Typically, that is the trend. Usually the taller you are, the bigger the shoe size. So we would say this is a positive correlation. And then the date of birth and your shoe size. Well, we would say this has no correlation because it doesn't matter when you were born, your shoe size could be whatever the size of person you are. So they have no bearing on each other. They have no effect. Next one. Here we would say this has a negative correlation because the line is going down. So y is going down, x's are going up. The next one, my x's are going up, my y's are also going up. So if they're both going up, this we would say is a positive correlation. Letter F, the outdoor temperature and the number of sweaters sold in the store. So the hotter the temperature, the fewer sweaters are sold in the store. So the warmer means less sweaters. Colder, so when the temperature goes down, the sweaters go up. When the temperature goes up, sweaters go down. So they're in opposites. So we would say this is a negative correlation. And then your hair color and height. Well, this is no correlation because it doesn't matter what your hair color, that doesn't have any effect on what your height is going to be. Next, let's match the situation to the scatter plots. So the number of trucks on the road and the number of days in the month. While they can vary, and there's not a specific day that there's more trucks on the road depending on the number of days in the month. So we would say there's no correlation with those. So that would have to be graph 3. The time spent driving and distance traveled. Well, if you think of rate times time equals distance, the longer you drive, the farther you go. So that would have to be graph 1. Because if you're driving, if the time goes up, your distance goes up. And then the number of months you own a car and the value of the car. Well, when you buy a car, it has a high value. But as you drive it, the longer you have it, it loses value, so it goes down. So we would say C would be graph 2. Next one, time spent exercising and calories burned. The more time you exercise, the more calories you burn. So exercise goes up, the calories go up, so it's got to be a positive correlation, which that would make it graph 2. The number of dishes washed and the number of ounces of detergent remaining in the bottle. So the more you wash, the less detergent is remaining. So that's a negative correlation, goes down. And the population of a country and the number of states in the country. They don't have any effect on each other. It's going to vary. There's no pattern. So that would have to be graph 3, no correlation. And our final one, use the trend line to predict the population in 2005. So we need to find the equation for the trend line. So picking 2 points that are on there, we could choose this point and we will choose this point. So 1960 here and 1980. So it'd be 228 minus 180 over 1980 minus 1960. So we can simplify this. So 228 minus 180 gives us 48. 1980 minus 1960 would be 20. You can simplify this by dividing this by 4/4. This would give us 12 over 5. And we would just put that as a decimal. That's a 2.4. And then the equation, we'll use the slope formula or the point slope. So y minus, and we'll just choose a point. We'll choose the 1960 and 180. So minus 180 equals 2.4 times x minus 1960. So let's distribute the 2.4. So this would be 2.4x minus, so 2.4 times 1960 gives us negative 4,704 by add 180. My equation would be y equals 2.4x and negative 4,704 plus 180 gives us a negative 4,524. And since x is the year, they're asking you about in the year 2005. So if I put 2005 in for x, I would have y equals 2.4 times 2005 minus 4524. So 2.4 times 2005, then minus 4524, y would equal 288. But remember, just looking at the numbers, the y, this is in the millions. So we would say about 288 million people would be the population in 2005. Now that's just a rough estimate because of the points that we chose. Now, if somebody chose two different points, they might have gotten a little bit higher of a value in there. But as long as you use 2 points that are on the line, you find the slope correctly, you use the point slope form correctly, and substitute 2005 in there correctly, your answer will be acceptable. So that is our lesson today on making and analyzing scatter plots.